Let's convert the rectangular coordinate to polar form. Here we have our xy coordinate, and we need to get this into the form of r theta. I like to draw a picture. Helps me visualize it, especially because in the end, we're going to want our angle to be between 0 and 180. So this makes it easier to check your answer in the end if you draw a picture. So go backwards 3, down 4, and here's our coordinate. Drawing a right triangle with the origin or the pole, we can figure out what the radius is. So the radius is going to be the hypotenuse of this triangle, and because of the world's greatest theorem, we know that r squared is going to be equal to x squared plus y squared. So we got -3 squared plus -4 squared, making sure we put those in parentheses, which equals 25, which means r equals 5. Putting our final answer, we know our radius is going to be 5. Now what's left is we have to find theta. In order to find theta, that's like the location of our coordinate, right? How far around we go. We're going to look for this angle. To find the measure of this angle, well, we have to do opposite over adjacent. So we're looking at doing tangent inverse of -4 over -3. It will always be y over x. And when you plug this in your calculator, making sure we're in degrees, we should get 53.1 degrees. Issue with that, though, is when I start at 0 degrees and I open up, well, 53.1 degrees would put me here. This point right there is going to be 53.1 degrees. That is not the point that we want. I need my angle to be between 0 and 180, but I can't have it. That 53.1 is not the correct coordinate. I need to flip over to this spot. Well, if I want it to flip and I need my angle between 0 and 180, I'm going to keep that 53.1, and in order to flip it, I just have to make the radius negative. Here's the coordinate that works for the given restrictions. Make sure you always pay attention to those.